Alright, this is the third video in the series. In the third video I've kind of delayed a little bit because I got a little bit busy. So I'm bouncing back from that busyness. So the third video has to do with cleaning up a mesh that has been scanned using photogrammetry. There will probably be another last video, two videos. One will be just printing, which takes 2 seconds. But the other one will address some of the things that I have learned through the time of the first video and this video. And there is a significant amount of stuff I have learned. One, greatly to increase the detail of the model, the speed of actually generating the model, and lighting, and not to mention the atmosphere around the model, how it needs to look, or the background, how that changed. So there's quite a bit of difference. All the other things will still work that I mentioned in all the videos. They still work. I just learned to do it better. So pay attention or make sure that you are watching out for that video. Alright, so the programs that we're going to be using in this video are two. One is Blender. Blender is essential in my humble opinion. This is the best program you could ever learn in life. It is also the hardest program you'll ever learn in your life. It's second only to After Effects from Adobe. So if you ever used After Effects for Adobe, you're fine. Blender is probably the next hardest one, and then ZBrush. And we are going to be looking at ZBrush also. So ZBrush is another three-dimensional modeling application, and it's worth every penny in my humble opinion, but it is very expensive. I was fortunate to be on the ground floor when ZBrush first came out, so I bought my copy of ZBrush, many copies of ZBrush, for $50 each. But as time goes on, now it's like $800 each. So it's a really good program, just very expensive. It might have gone down, but I doubt it. So those are the programs. So if you go download Blender, you could follow along and kind of look at what I'm doing. And you'll probably need a mesh that you scanned. So 1% of the actual population in my channel who has scanned something, they can follow along with this video. If you haven't, at least you know what's entailed for you if you go this route. Okay, so I picked one of the harder files. The muskrat that I scanned in the last video turned out great. There was really nothing to learn from that. So I did choose one that did not turn out as good, and I'll show you how to clean that up. All right, sweet. So download Blender. This was version 3.0 at blender.org. And then go ahead and open it, and then we'll continue from there. Alright, so we got Blender, and we got some scan data. So what I'm going to do is open Blender, X on the keyboard to delete the stock square, and then import the OBJ from the Edgesoft program, Metashape. And depending on the density of the mesh and everything, it takes a while. So this is often the case when you go to use Edgesoft Metashape. There's a mesh in your scene. You can see it right here. It's really jacked up as far as like way off in the middle of nowhere. So our first mission is to get it over to here where we can work on it better. So that's this first part of the video, is just centering your design. So we always do that in object mode. What I like to do is just, there's probably some artifacts on it. So here's that. Let's go to edit mode real quick. Go to mesh, go to separate by loose parts. You can see that it has been split up into all these little parts. Okay, and let's go to object mode. Alright, so what we want is just the main rows and not any of the artifacts. So if you highlight it using the left mouse button, you can see which one is the real one and all the artifacts. So we delete everything else. You can highlight the good one and just go select invert and X delete. And that deletes everything but the mesh. Good. Alright, now we have to get it to the center of the screen, so we go to Object, Set Origin, Origin to Geometry. That brings the origin of the piece over to it. We go to the Move tool, and you can see that I can bring it over using the arrows. But if you hit N on the keyboard, you can actually type in the location of 0, 0, 0. Okay, and now we can rotate it into position. Now this is a plant, so it doesn't have an XYZ, except for, you know, like we know what up and down is, but we don't know what the front of the plant is correlating to the back of the plant. But what you usually do is you'll rotate this until you can see this green line, right? So if you hit Y up here on this little doohickey, you will should be able to see the front of it. So we always align the front to Y, Y positive. So just to be clear about that, let's pretend that this is the front of the flower, right? I hit Y, I go like this, so that leaf, it's got a nice vector point here and here. You can see how even that looks. I go to X, I do the same thing, boom. And I kind of center it down the center of that one, and I center it down the center of this one, and there we go. That's how I do that. And lastly, because I've rotated the object so many times, we go to Apply Rotation Scale. Boom. So now the design is center, and we go File, Save As, and this is where we're going to save it on the desktop, called Rows. Alright, so here's the navigation of the program. Middle mouse button, click and drag to rotate. Shift middle mouse button to pan. And lastly, zoom is the wheel mouse as a scroll. So between scrolling in, panning, rotating, that's actually the hardest part for most adults to do, is this navigation, especially the ones that never play video games. So if you haven't played video games, you are significantly handicapped using Blender. A lot. So, buoy for you for holding out. So, fun time. So that's how you navigate. So just kind of if you just have the square in your scene and you want to navigate, try to rotate around it, try to get underneath it, everything else. All right, next we're going to look at these problems that occur. There's three major problems that occur in any kind of scanning of a three-dimensional object, and that is, 1, there will be holes in the mesh. Okay. 2, the outside edges of anything that is pretty much organic will kind of look like this. So especially leaves, flowers, anything like that. So you can see the many holes that we have in the mesh and these kind of like bite marks in the mesh. The third one is this. You're going to have maluniform geometry or non-manifold geometry, and that's caused from any opening that have occurred, like this was mounted in a piece of foam, and that means it couldn't scan this area. Okay, so we had to fix or learn how to fix those three problems. And once you have those three problems down pat, it's really easy. It's just repetitive. Now in the newer ones where I'm scanning, actually I'm scanning with a darker background, and I've noticed there is a significant drop of these artifacts that appear. Another thing that will occur is, let's see this surface noise. You might want to keep that around. I know it looks bad, but actually in a 3D print it looks really good. So surface noise does look good. If it doesn't have any surface noise, it kind of looks like a toy. So if you see this and you know a rose doesn't have this, you might want to keep it anyway. Alright, so let's begin by fixing holes and learn how that works. Alright, so to get a hole fixed, you just go into edit mode. Okay. You go into vertice mode, which is this one right here. Alright, what we want to do is go into lasso select and lasso select the area with the hole. Okay. Then you need to rotate and hold control to lasso away anything that was in the outside of the hole. So in other words, you don't want anything over here, you just want the hole. That's the fastest way I've learned to highlight that area. There's a couple other ways I'll show you, but for right now that's the easiest way. Okay, so once you have that, you hit X on the keyboard and you hit collapse edges and faces. Boom, hole fixed. Okay. Now this geometry is very bad. It doesn't really matter, however, in 3D print land how bad it is. It will be a problem if we go to ZBrush, however. So I'll show you how to fix just this one hole first. So you go into sculpt mode. You go into this brush called simplify. You go over here to the square and turn on wireframe. Then you go over to the wrench and screwdriver and turn on dynatop. It will warn you about something, ignore it, just hit OK. Under dynatop you'll notice that there's a pixel ratio here, or point ratio, whatever, they got this weird measurement, but basically the lower the one, lower equals the higher polygon count. Okay, I don't need a lot, but I'll show you what it looks like. So here's 3. Click on it and give it a sec. See how dense that is? Okay, so I don't need that density. 12, better. Okay, so you got to kind of play with it until you figure out a density that you need. So that's how you clean up that area. Now if you look at the back side of it, backside be alright. Let me navigate to that back side, which was, oh, here, right there. So you can see here's the back side of it. It's all good. Now sometimes when you collapse geometry, it gets thin. So what we like to do is puff it up. So to do that, you take dynatop off, and then you choose the inflate tool, and just kind of give it a once over. Now it doesn't matter if it's all scrunched up, and holding shift evens out the geometry too, by the way. So you go like that, you can hold shift and it just relaxes the geometry. It's called the smooth tool. So it won't matter if there is too many holes here because we're going to be using ZBrush to clean it up. That was too big of a hole to fix in ZBrush, however. So our main objective is to get rid of all the holes. It takes a while. So let's look at the other way to do it. Edit mode. All right, the other way to do it is to get the hole in clear view. Okay, hit C on the keyboard with vertice on, and you can just paint a selection. Once you are done painting the selection, you hit right mouse button. Should get that one too. Now you're left with the same problem though. You have to go over here and deselect this stuff by holding Control and then lasso it away. So I don't like using that method to do it because you're stuck doing two operations and your brain is kind of wonky between it. So that's a way to do it anyway. So X on the keyboard, collapse, boom, boom. Then again, you could do many holes at once and then go into sculpt mode. I'm just getting you used to going into sculpt mode to fix it. So sculpt mode, that one, dynatop, okay. And boom, fixed. Boom, yeah. There we go. So that's how you clean up little holes in mesh. So now, how do you clean up bite marks? We're going to use this bite mark right here. How do you fix this? All right, so to fix a bite mark, we go into edit mode. We could either use the selection method with C, with the brush, or we can use the lasso tool. I'm going to use the lasso tool. I'm going to highlight all of this data, just like that, where the bite mark occurred. Whoops. Boom, 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 bam. Okay, so that's the bite mark I want to get rid of. All right, so after I got the bite mark highlighted, I'll hit X and go collapse edges to faces. It's going to be ugly looking. See? Ooh, that's okay. What you do is you take this one point, okay, go to the move tool, and you're going to position this where you want the bite mark to be fixed. So I want it to be averaged right here. We still got a little bit to go, but that's okay. This is a good start. So I'm going to put this up in the air, and then I'm going to go over to sculpt mode. And then I'm going to go into my simplify, again dynatop, and then OK. Then I'm going to repair this area. Boom. Okay, good. I'm going to kind of hit this area too. I don't like this little thing, so I'm going to hold shift, and then I'm going to click on it without shift, and that'll get rid of that. So now I got this area cleaned up, and I got one more bite mark. So I just repeat the process. I go into edit mode. Highlight the vertices. X on the keyboard. Collapse edges and faces. Move the vertice to an area that is kind of average. And then I might have to jump into a different camera just to get it positioned well. Like that. And then once I get that done, I go into sculpt mode and repeat the process over and over again until I got the area clean. Dynatop, boom. What you're going to find is if you do this, like let's say you're cleaning up a mesh, it's really easy. It's kind of relaxing actually. It's not hard. It's just, it is time consuming, but it's kind of like a micro focus thing. And the more you clean up, the better it looks, obviously. Let's see if I can find any artifacts while I'm here to kind of show you. Let's see if there was stray artifacts that were just huge and hard to repair. This brush right here that I got on, the Simplify Dynatop, will clean up just about anything. Let's say this area, right? This won't be bad 3D printed, to be honest with you, but if you wanted to clean this up, you can just hold shift, okay? And then again, no shift. Shift, no shift. Okay, shift, no shift. So you can start just evening out this area so it doesn't have so much noise. You can see the noise. Easy peasy, right? Yep. Again, you might want to leave most of that noise there though, because on a 3D print it looks pretty good, even though it's ugly in the 3D program. Okay, so that's how you do that. Now our last problem, which is this, the maluniform or non-manifold geometry. How do you fix that? Holes in the mesh. All right, to fix a hole in the mesh, you go into edit mode. You page over to edges, this button. You go to select by trait, non-manifold. And that highlights this edge or any opening of anything. So if there might be some edges up here that need closing. And then Control F. Control F. That's on Mac or PC, Control F. So fill. Boom. Now this opening right here is bad when it comes down to opening it in ZBrush. So we're going to fix that up. So to do that, again, I go to my favorite tool, Sculpt Tool, Dynatop, boom. Just hit it with them. Dynatop Love. This one's going to take a little bit to calculate. The larger the change, the harder it is to calculate. There we go. And just give it a little once over here. Make sure they're all triangles. All right, we're done. Now, this mesh right here is actually so small, okay? These are in millimeters. So right now, this rose is 1.18 millimeter. It says meters, but in 3D print land, this is millimeters, okay? So let's go to object mode and repair the scale of this to match real life. Okay, we're going to go to scale, and then we're just going to scale this up. I'm going to scale it up to about, I want to say 110 millimeters. Now let's go 100 mil. So this right here is going to be 100 millimeters. Now you notice this is 100 millimeters in X. So that's going to be here. But 197 millimeters tall. So actually I want the tallest to be 100 millimeters. So I'm just going to back that up just a little bit. There we go. So the tall part of this is 102 millimeters. That's only because worst case scenario on my 3D printer, it's 110 millimeters that I can print out width-wise. So it's easy to identify when you plop it into the scene. You can see it and you can rotate it very easy that way. You can always shrink it later on if you want, but it's better to have it too big than too small, I notice. All right, to fix this, so that, see the scale is 58%, we want that to be 0, so we go to Object, Apply, Rotation Scale. Now our scale is 1, which is good. Our dimensions are good, and now we can export it to a different application like ZBrush. So I would save anything in Blender first. You can always go back to Blender that way. Okay, and then you go and make sure you're in object mode. Highlight the object, export, and we want wavefront object. Where is it at? There it is. Wavefront object. Again, if you didn't see me do that because it was fast, export wavefront object. Boom. We want this little guy right here to be on, selection only. Always turn that on. And there we go. So obviously before we export, we would clean up all the holes, we clean up all the geometry, we make sure everything was perfect, and then I'll show you why we go into ZBrush in the next video. Alright, so I'm in the newest version of ZBrush, which is the 2022 version. So I'm just going to import over here. And let's go into desktop, where I imported the rows. See, the rows is 165 megabytes, which is fine. Once it says this, I say yes. So it only had 2 bad vertices, which is not bad at all. You turn off Lightbox. I don't know why it does that. So click and drag, and then hit Edit. Now you can rotate around the mesh. You don't need any special keys for ZBrush to rotate, but you will be using these a lot. So this is your move, this is your rotate, or no, zoom, this is your rotate, okay? You can also do that in the viewport, but the problem with that is, let's say I'm zoomed way in, right? Okay, as I zoom, I gotta click here, and now I'm zooming, but again, if I got the whole viewport being taken up by something, I have to use these keys over here. That's obviously the most non-friendly way of moving in a 3D application. Because you will get to the point where you're like zooming and you're like over here trying to click just to it. You'll see. Yeah, if you use this program enough, that's the only downfall of this program. Zooming into an area, moving around in it is strictly cancer, but is the best 3D app when it comes down to this stuff, details and everything. So in this program, I could sculpt on it. I could sculpt in it in ZBrush or Blender too, but this has a feature in it that's called dynamesh. Okay. And that's what I use. So geometry and then dynamesh. So right now, here's the polygon structure of this. Okay. What I'm going to do is I'm going to up that by going all the way up here to 4096 resolution and hit dynamesh. What this will do is redistribute all the polygons to a very, very uniform structure instead of all over the place. And this will allow you to sculpt on it, change it, do whatever you want to it. It'll also allow you to repair small things. So I'll show you how to do that here next. Alright, let's look at repairing things in ZBrush. Let's look at our hole problem. We got holes, right? They got some holes right there. And here's what I was talking about with the hole moving. I see a hole right here. The brush is really big, so I'm going to shrink it up. And I'm going to go in to use a brush called Inflate. Here's all your brushes, and it'll take you 12 years to learn them all. but here's this. Inflate is one of my go-tos. And I just inflate this area. Notice the hole is gone. Hole's gone. I could probably do that over here too, this hole. Just inflate it. Those holes are gone. And what I do is hold Control and click and drag. You make this little box by doing that. And what that does is it rebuilds the entire mesh to support your change. So now those holes are gone. So if I see any holes, boom, boom, Control, click, drag. Obviously you get some distortion here now, but you can hold Shift and even that out, or you can go Subtract and de-inflate or deflate the area. You can also kind of touch up a little bit here and there, you know, just to get rid of some of the fractal noise. Again, noise is your friend though. Noise is your friend. So if I see in our hole here, boom, fix that one, Control, click, drag. So you can see I just was able to repair all of that in this program way faster than I could in Blender. But you can't fix bite marks as easy. So bite marks be a little bit more difficult. To fix a bite mark, I inflate it with the inflate brush. I kind of smooth it out a little bit, inflate it, smooth it out, and then I go into another brush called Move Elastic. There it is, that one. So now Move Elastic, I can kind of just go like that. So I guess you can. I mean, that was pretty easy, but so between Move Elastic and Inflate, just to kind of fix and repair it, and Shift to smooth it out, you could do a lot of stuff in ZBrush. The other thing I use in ZBrush a lot is the slash tool. Okay, it's under S. So /3. So the intensity is just a little too high on this brush usually, and you can use the bracket keys on the keyboard to make it smaller. What I usually do is strengthen up small cracks and crevices with this. It's a small change. Here, let me show you. And here's what it looks like. You can see that I just make a crack right there if I wanted to. So these small changes are huge when 3D print them. They look good. They look really good. So you'd want to go in here and strengthen some of these cracks and crevices up with this brush, and you can just guess the intensity of it. You can see how much sharper that looks. Okay. This also works great for skulls. If you want the different hemispheres of the skull, you can just lay down that crack between the two hemispheres. Oh, there's so much to show with ZBrush. You can get into a huge, huge thing. Maybe I'll do one more. This one's super complex, so just bear with me. I don't like this, okay? When I go to 3D print it, it's going to be out there. And if I go to plate it with copper, it's going to be out there. So I'm going to fold down this leaf. Okay? How do I move that? So again, this is rather advanced stuff with ZBrush. So go into Mask Lasso. Okay. Control to highlight the area that you want to bend. So now this is masked off. Over here, we want to go to masking and inverse it. I also want to blur it so it doesn't have a sharp edge. And then I'm going to go into a brush called the transpose tool. This thing. So first unlock it, don't touch it. Get it to, you're going to have to like move around and develop this as a fulcrum. So Doesn't matter which fulcrum you use. I'm using the X as the fulcrum, but it's in that area, and pretend this was going to be rotated, right? So once you get this thing moved, rotated into the area, you lock it, and then you can just go like this and start folding that leaf down. Okay. Just like that. Now, if I want it completely folded, right? Completely folded, I'm going to have to clear the mask, control the area to put a new masking point down, blur it, move the fulcrum. Oop. Command Z to fix that. Unlock it, move the fulcrum, lock it, and just start moving it. Now notice I'm moving the rows this time, but that's okay. It's either moving the rows or moving the leaf. I don't care which, as long as it's the leaf is straightened out. So clear that, and that's all your workflow is just going in here, unlocking it, moving the fulcrum. So this program allows you to move huge amounts of polygons. Clear. Even, like by animation standards, if you were to try to move this many polygons, it would not work. So you're gonna just kind of move around to see how bad. Now, it used to be way out here, now it's way up here, so that's good. The other way to mask off something is the mask pen. So let's pretend I couldn't get into this area very well. So you clear the mask. Oops. And you can use mask pen with the control key, and then I can get up into this area. It's not as easy with the transpose tool active, so I usually go to inflate for this, and now I can paint a mask in this area. So if I wanted to get a mask way up in here to rotate this, I could do it that way. If I made a mistake, it's Control Option or Control Alt. So Control Alt will deselect, Control will select. And yeah, you just get so used to like switching between the tools, but there's so many tools. Okay, that looks good. So sometimes you have to highlight something and then come back over here and Control Option, get rid of it like that. And then again, always blur it and transpose it. So you can move it like that too, then move it like this. There we go. That's actually a lot better right there. So I might want to, because this leaf got rather thin, I can clear this out, and to repair it any further, I can just go to the inflate tool. I can get rid of any anomalies that occurred. I can smooth it out. I can inflate it. I can even inflate it past the anomalies that occurred. Like that. And then Control, click and drag, and that will build this area into one solid chunk, and then again I could just go like that. I have noticed that when you go to 3D print this stuff, you do not want any weak areas, so you might want to strengthen up little areas here and there. That way when you go to 3D print it, it's got like these right here, just fatten them just a little bit. That way they're not so brittle. Cool. And if you don't like this, the last tool is flatten. I use that one a lot too. Okay, flatten just does this. So it evens it out. Nice. You won't notice too much about the change between this and that, like this noise versus this noise. It's going to be a very small, significant change. All right, cool. So that's all. That's a lot of the changes right there. And trust me when I say there's a lot of tools to learn, way more than I could ever teach in one video. But let's go on to the next part where we turn this into a 3D printable object, because right now it's 2.5 million polys and it will never fly that way. All right, so we're going to fast forward, pretend that, like here's this one I moved. I need to move this one, but let's pretend that we're in the tail end of this video where I have to export, okay? So in order to do that, we go first save this as a Z tool. So make sure you save it somewhere. That way you can always get back. Go to Z plugin and go to decimation master. And then we go pre-process current. This takes a minute. So our end goal is to get it to like 450,000 polys, only because if we go to print one or two of these in the other program called Chittabox or any other 3D printing application, it takes a lot of memory. Yeah. So we want to lower that down. There's no way we need 2.5 million polys. Okay, so this is what it looks like before. I'm going to turn on polyframe. You can see how dense it is. I'll zoom in. Okay, just to show you. And then let's go into Decimation Master and choose a percentage. I'm going to choose 10%. And then I'll hit Decimate Current. Boom. So look at that. It's down to 259,000 polys. Now if I don't like that, I can hit Command Z and I can choose a different one. Let's say I chose 19% or somewhere. In there. Actually, I like the 476,000. So it gives it some noise, but it doesn't take away anything. So I'm going to it looks absolutely the same, right? So with this, with doing all this, with dynamesh and everything else, what that did is made this a perfectly good piece of geometry that doesn't have hardly any flaws when it goes to 3D print. And it takes away all the maluniform geometry and everything else. So now I can export this as a STL. Boom. Now, if I didn't want to spend the $800 on ZBrush, I'll show you how to kind of do that in Blender just a little bit. I can't do any of the mesh deforms or the dynameshing or anything like that, but I can show you, like kind of the pole man's version of that. Okay, so I'll show you that next. Okay, so this is how you do that in Blender, which is absolutely free. I couldn't move these very easy. Okay, so I can't do that. There's probably ways, but I don't know if they're worth it. So go to wireframe, turn that on. we're going to go in here, and the first thing I want to do is eliminate any problems that occur. Okay, and that's these little spider webs and all kinds of stuff that happen from collapsing geometry. Okay, so you go over here to the wrench and add a modifier called Remesh. This is going to take a huge amount of processing power too, compared to ZBrush. So you go to Smooth, you type in 8 or 9, depending how gutsy you get. So you can see that even 9, you almost need a 10 to get it. Okay, so there's 10. You can see the difference though. For example, see this tessellation that occurs? That is never going to get fixed in Blender. Okay, that's the difference between Blender and ZBrush. Blender can't fix these areas. ZBrush will fix these areas. So I doubt you'll have that much to clean up like this rose. This rose was pretty horrible. So what we do is go to apply it. You could spend some time with the sculpt tool and hold shift in those areas. We're going to go right into decimate. So now we're taking a remesh and just decimating it. Before I do that, I turn on wireframe just to see. This is the polygon structure. You can see which the difference between the polygon structure is octagonal versus the quad that occurs over in the other area. These are quads, but they're put together in a funky way compared to ZBrush. All right, so we got decimated. Now we just choose it percent. Let's say 25 or 24. Enter. Aha, her. It does not want to decimate. Okay, I can just click and drag too. There we go. Oh, 0.25. Haha, that's why. There we go. There we go. So to get a polygon count in ZBrush or Blender, yeah, let's go ahead and apply that. Oh, there it is. 540,000 right there. So a little bit more, but not too bad. And now we can do the export. So export STL. So this one, I'll just do blend. Selection only, and export still. So if you wanted to bypass ZBrush and get kind of the halfway detail of things, you can do that. And if you know Blender enough, you can, again, sit here and using the sculpt tool, you can probably, put in the details, everything else. I just prefer ZBrush. All right, so that is the how to get it out of Blender, how to get it out of ZBrush, how to clean it up, how to repair some of the mesh problems, the three main mesh problems that happen. That's it. This video was kind of short, in my humble opinion, so I might just combine it with how to get it into Chittabox and show you the print portion of it. All right, so this is Chittabox. Okay, Chittabox comes with the Elgu Saturn. That's what I use, the Elgu Saturn, non-S, only because I know the parts are easier to get than the S, but yeah. So if you get an Elgu Saturn, you're in good shape. Chittabox comes with it, but it's the free version, and that's what I'm using right now. I do have the Pro version. I don't see a significant difference. I'll show you what it is, but I don't use it often unless it's a very delicate part. Okay, so if you're printing in very, very, very detailed things, you'll need it. But if you're not, you don't have to, as long as you have the patience to cut it out. Okay, I'll show you where that. I'll tell you where when we get to it. So in order to add the rows, you just go File, Open, and of course you want to add your machine too. So there's a way to add your machine into Chittabox. That's been a while since I did that, but I don't think I did it with this one. So settings. Might not. Let's go to settings over here. Settings over here. Yes. So yeah, I did add it. So there's the Elgu Saturn. So you can just hit plus. It'll ask you what you have. Elgu Saturn. Let me hit OK. And that'll bring in the dimensions that's needed. You might also want to check whatever resin you're using. Like I'm using a Cyrex resin. And you might want to put the actual dollar amount here. Okay. And you can actually go in and do everything for that type of resins too. If you go to their website on any resin, it'll give you these settings. They're not horrible when it's out of the box though. You know what I mean? I changed all these. I didn't see any change whatsoever. It wasn't that much. It may be a little bit of speed difference, but not much. So I just kind of left it alone. I still leave it alone. All right, sweet. So we open. Boom, plops it in there. Okay, so you see that it's at an odd angle. What we do is go to rotate. And you want to rotate your objects so, especially if they're flat. I'll give you a big hint. So, unfortunately, there's no flat spot here on this one. But you want it at a little bit of an angle. So let's say this was like this, right? Under here, there will be a buildup of old resin, okay? And it won't drip off. So we don't want that. So if we rotate it just slightly, now this is at an angle and it will roll off a lot easier, okay? So you never want a flat spot, especially if it's like a flat object. You take your flat objects and put it at a slight angle so that the old resin, as it lifts up, just goes back into the little holder. Okay. This is probably a bad idea too, because that will be a pain to clip off. So I'll put that part out top. And I will say, Chittabox is by far the least friendly to any video card ever. And it runs, but it certainly isn't streamlined. So there we go. Got that little thing popping out. Got this at an angle. Got this at an angle. All the other things are at angles. I can go to move and say put on plate. Very good. So if you ever want to copy it, let's say I want to print 2 of these, you can just go up here and there's a copy command. Okay. You can see this red area tells me that it's below the line now. So I can put on plate or I can move it. You can also scale in this program. So you just see you want the scale to be 50% of the other one, just to see what you can print or how small can you get it. Again, I'll go move, put on plate, put on plate. If I see this red though that it does, sometimes the program's not smart enough to put it on the plate, I'll move it up so there's no red. All right, once you get all your objects in here, you just go over to your supports. Now I could do both supports at the same time. So I'll just highlight both objects or select all. So we want light because we got small parts. You'll see that there is a contact diameter. Okay, the contact diameter is, or diameter, right here is what I was talking about in the other Pro version. It just has a better interface when it comes down to it for doing this. So you can kind of see it. It gives you a little mouse over. The other one shows you a little bit better interface. Both can change, however. So again, I'm just not seeing the need for Pro. I'm sorry. It's just got a better interface, but you can still make the change. You just got to know what this is. So smaller allows it to be, if I have this little thing right here, I can cut this off the mesh a lot easier. Okay? Because when you print it, and I'll try to make a smaller one, see if it changes it. So you don't get a real-time preview of what it looks like. You can only say that's small. Cool. If that makes sense. You will know what I'm talking about if you go to cut all these off. Trust me. So remove all. I'm going to have the computer generate it. Light, I'm going to put that at 0.12, and then I'm going to go in here and hit all. Boom, boom. There we go. And if you want, this is what I do. I go to heavy, and I'll put one like here, here, and anywhere there's a big bulky area or a bigger area, like that. So I've noticed that helps. Because when I'm going to cut these really small, delicate ones off, these will hold this in place, and I can cut those two last. All right, once you're done, you can go back to this, and you hit slice. It'll give you some things. It'll tell you how much this is. So this rose, both roses cost almost $1. So you can kind of see the this is what I was kind of preaching about. If you know me, I also teach electroforming, and I've been switching over to a 3D print workflow. from organic to 3D print. If you could think about it, like 0.98 cents, right? You got this little object, you plate it with copper, and like you sell it for $10. Okay, that's like what, 90% uptake. It's a huge uptake. So you can see the profit in it. I mean, like there's you can make earrings out of anything because you could just print duplicates of stuff. Okay, so it's not only advantage to get off the fact that you're putting nitrates in your acid, but also you're able to print out clones of things and any size too. Like so, I scan a stick, I could print the stick small and make little tiny things easy. No nitrates involved, and the stick probably costs like what, 50 cents. It's a huge uptake, especially if you're scanning skulls. Skull on eBay will cost you, roughly about $20 to $30 for a real skull, and then you get it all in your tank and plate it and everything else. Versus you print it for maybe $2 and you plate it. Good times. So rose. And that's it. What you do is you put that on a flash drive, which is a USB flash drive, and you can just take it over, plug it in, and hit go, hit print, and it'll see the file. It'll see what you named it. I named mine Rose, and away it goes. 3 hours 45 minutes later, you'll have a cool plastic rose. Nice. All right, so this has been fun. This is the, I would say, third and fourth video combined into one. The cleanup of the mesh and how to get it over to a printing application. I'm just using Chittabox because it comes with Elgu Saturns. You can use, there's a couple other ones too. Prusa makes a good one too, but you have to adapt it to work with the Saturn. It's not hard, but I would say just use Chittabox. It's not that bad. Cool. Been fun. And I'll see you in the uptake video where I show you, some of the changes that I've made between the first video and now, as far as the workflow for scanning is concerned in the next video.